Hi guys. So when I was buying some chips recently, I came across this TP5400 IC, and its purpose is to provide battery management in that it actually handles the charging of a lithium ion cell, but it also has in it a boost switch mode boost circuit to output 5 volts. So you can have in one little 8-pin package, you can actually charge the lithium ion cell and also generate 5 volts for your circuit for it. And that's a common use nowadays for putting a little lithium ion cell in some circuitry that needs 5 volts, digital circuitry. So they have managed to put it all in one little package here. So we're going to try that out. Normally you would end up with at least 4 little packages for the battery management and one for the boost circuit, but we're going to have a look how good it is to do it just with that one IC here. Now the only thing about it is a Chinese device, and the only datasheet I have come across is in fact in Chinese, so not much chance of actually reading it. Now this actually is a common diagram here for what a lithium ion cell needs. It starts off at constant current, and then once it gets to 4.25 volts you will want to put it in constant voltage mode, and it then trickle charges it and so on to end the charging cycle. So here is a recommended circuit which I have implemented. I don't have a TVS diode, so I didn't put that in, and I'm not sure what the 0.3 ohm resistor is doing over there. I can't read the Chinese, so I don't know anything about that, so I've omitted those. And the little package has a little pad underneath which is actually used to dissipate heat. So we will have to solder that up with hot air, because you can't get the soldering iron underneath, obviously. So this is the circuit. As I said, pretty much similar to what they had there. There is 2 LEDs, the charge and the standby. One's going to be red, one's going to be green. A couple of capacitors on the input circuit to filter it just in case some noise came in with it. I put a USB-A socket on there. Of course you can put any kind of socket on there, including USB-C. This is just something I had laying around. This is a test circuit to see how it works, so it's by no means a final. Okay, so then on the output here there's the Schottky diode and the inductor to a typical boost circuit that will output 5 volts. I put in a little fuse there because I had it laying around, so I put it in. A couple of capacitors and some extra filtering I decided to put on. Not sure if it needs that, but might as well put it on and see what happens. So this is the little PCB board. Now the idea about this is that in the final version, if this actually works, that I will take the lithium ion cell, and it'll be a 18650, and I will spot weld a couple of little nickel iron strips on there, and they will go through those pads over here But you'll notice in the board that I have, I actually omitted those pads. I'm going to actually solder some wires onto it and use a battery holder before testing. And but in any case, the idea would be to solder on the strips over here, the nickel strips that are spot welded onto the cell. And this little board is the same size roughly as the 18650 cell. This is where the little TP5400 chip lives. And if you look at this pad over here, there's actually another pad available that has 4 tiny little vias in it. And then on the other side you could then put a larger piece of copper for heat dissipation. But I am making my test circuit on a homemade PCB, single-sided, so I don't have that facility to to do that, so I left that off. I am not planning to draw more than maybe half an amp, somewhere between half an amp and 1 amp at the most, so it should be fine. Yep, she's working. Got the multimeter in diode mode, so I can touch it and it lights up. And now we need a resistor. It is a 1.2K resistor. This copper got heated a little bit by the hot air, and it's got some little bit of corrosion on it, so I just want to make sure that the solder is going to take. Okay, I think we are all done, so I'm going to clean up and then next there will be some testing. Okay, well, I have been experimenting with this little board here and it got mixed results. I am not sure the output. I'm currently drawing 200 milliamps out of this, and if I draw more than 200 milliamps the voltage out drops below, well, I can actually show that. Let's draw 300 milliamps. The voltage drops below 5 volts, 4.68 volts. That wouldn't be very good if you're running a 5 volt circuit of that. So therefore it appears that 200 milliamps is about the maximum that you could draw, and at 100 milliamps you actually get 5 volts. So the regulation isn't wonderful because of that. And another thing is that if you plug in, the battery charging circuit works well. I've already tested that. So let me plug in. See, the little red LED comes on because now it's charging. Look what happens to the voltage. We've got 3.8 volts now instead of 5 volts. So when you are charging, you can't actually draw the current out of this chip. So I'm not actually sure what that 5 volts that this chip produces is really good for. And I would think that if you're going to use this chip in a circuit, it certainly works well charging. That 5 volts out is kind of useless, and you would probably want to put a switch there or something, so you'll switch this from charge to or a little relay or something that as soon as you plug this in, it disconnects the output voltage or something like that. But I think you would still need to add a little chip there to do the boost conversion yourself with something else. That's what I have seen to be coming up with. I tried different inductors, and I've tried a toroidal one and so on to see the output ripple was absolutely atrocious. It's like 200-300 milliamps of ripple on it as well. I haven't actually tested it with this inductor. It seems to work better with this kind of a shielded inductor on it, but I think my testing so far is that okay, if you want to charge a lithium ion cell with this thing, well and good, but I would not recommend using that output voltage because it seems to be not good. As soon as you unplug it, it'll go back up. So that is what I have found. So I thought maybe it was a good idea. Maybe with the little one chip there, we could actually have the boost converter and the charger in one, but my experience so far says that it isn't. Now if you look, you will see that right now it is drawing 600 milliamps. I've got it programmed that it can draw up to 900 milliamps. I got a 1.2k resistor on the program pin, but this battery is almost, getting close to full, and if you leave it plugged in, I have noticed that it goes to 300 milliamps and 100 milliamps and so on, and at some stage, and then the little green LED on there will come on and it says, hey, I'm in standby mode, and it's kind of like a trickle charge mode or something like that. So as I said, the charge circuit is just fine, but the that voltage out, I'm not sure. And the thing is that I don't have a English. It's of course all in Chinese, and I don't see any references there Let me turn on the little cursor so that you can see where I'm pointing at. I see no references there about how much current this thing is supposed to be able to draw on the output. It's all talking about the charging and so on is its main reason for being, I think. And V out says, okay, V out is 5 volts, but with a load of 1K or something like that. I mean, and it goes from 4.8 to 5.1 volts. But if you put a load of 1K on 5 volts, then you're not getting a great deal of current, are you? So, and I can't read the datasheet to see what that V out actually is for. Anyone's watching this and you know Chinese and you can translate that, please tell me what that says about what V out is for. And if you look at this little diagram over here, this doesn't make much sense to me either. V out goes to a resistor network. I mean, that can't be right. I mean, there has to be, I would think that there would have to be some circuitry to drive that or something. Unless V out is actually not V out, but it is meant to be a some sort of feedback. As I said, it doesn't make much different sense to me. And I've got a 1.2K resistor on that program, so it'll do 900 milliamps. And at 900 milliamps, I've noticed it gets pretty hot, but not within the specification. Anyway, so that's what I found with that little cheap TP5400. There's also a 5410. I'm not sure what the differences are. But in any case, this V out over here, it says I out, but there is no indication in the datasheet what the I out is actually meant to be. I only see some sort of trickle charge, 200 milliamps or something. Okay, so I'm gonna leave it at that. The little chip TP5400s, I got 4 or 5 of them. I might use it just for charging and ignoring the V out, because the regulation is poor. It doesn't have much current outputs, and also the voltage changes when you plug in the 5 volts for charging, so I can't see what that is actually useful for. Any one of you knows different, then let me know. So don't forget to subscribe and like if you like these videos, and I'll be looking for some other controllers. I'm still not happy that about some of those boost controllers I tried. I'm going to have a look at some proper brand name ones and see how they perform, maybe Texas Instruments or whatever. And I'll do videos on those when I find them. And I'll see you guys later.